this video, we will be discussing how to make 5-number summaries and how to make box plots from that information. So the 5-number summary includes the minimum value and the maximum value, along with the first quartile, the second quartile, and the third quartile. Now the second quartile we've already talked about. That is called the median. So let's discuss what a quartile is. So the first quartile is labeled with a Q sub 1 right here. That indicates the first quartile. And that is the value so that 25% of the data values in a set are below it. The third quartile, labeled Q sub 3, is a value such that 75% of the data values are below it. And then the 50th percentile, the second quartile, is Q2. That's also the median, and that's because 50% of the data values are below it. So if you remember from your mean, median, and mode section, your median was the middle value. So if it's in the middle, that means 50% of the values are below it and 50% of the values are above it. So that's always your Q2. And then what's happening is you use your median to split your setup into 2 groups, and you're finding the middle of each of those groups. So the middle of the bottom half is the first quartile, and the middle of the top half is the third quartile. So again, the first quartile has 25% of the data below it, the second quartile has 50% of the data below it, and the third quartile has 75% of the data below it. You can use that information to graph a box plot. So let's see how we use all of this. So here's our first example. And by the way, thank you to Scottsdale Community College for writing the College Mathematics First Edition textbook. It's a free online resource. So if you want more information, you can go find that textbook online and get more examples or deeper understanding of some of these topics. So the first example, suppose we had recorded the heights of 8 females in inches as being, and we have them listed. Find the 5-number summary for the data set. So it's always good to go ahead and order your data. So I'm going to start with the smallest value, so 59, then 60, then 62, then 64, 66, 67, 69, and 70. So there are my 8 data values in order from least to greatest. So the 5-number summary includes the minimum and the maximum. So the min is 59, and the max, the largest value, is 70. So those are the easiest to find if you've got them in order. And then the median, we're used to doing that. So let's go ahead and find the median. So the median, we want to look for the middle number or the middle 2 numbers and then find the average of those 2. So in this case, I can cross out the lowest and the highest, then the second lowest and the second highest, and I keep going until I get to the middle 2, which are 64 and 66. So since there are an even number, I'm going to add those together and divide by 2. So I'm going to average them out. So 64 plus 66 is 130, and 130 divided by 2 is 65. So the median is 65. So the median, which is Q2, 65. Another way to do this is using what's called the locator. So the locator depends on which quartile you're trying to find or locate. So let me show you how to do it with the median. So for the median, your locator, and let me show you what I'm talking about up here. I have the information. Well, I have it for 25 and for 75, but it's the same thing. So for the first quartile, since it's above 25% of the data, you can use your locator, which is L is equal to 0.25 N. N is the number of items you had in your set. For the quartile 3, Q3, since that value is going to be above 75% of the data, your locator is 0.75 times N. For the median, your locator would be 0.5 times N, because your median has 50% of the data values below it. So if I use that, I get L is equal to 0.5 times N. N is 8. So 0.5 times 8 is 4. If you get a whole number, you're going to use the whole number plus the one after it, and you're going to average those out. So what you're looking for is the data in place 4. So data value in spot or place 4, and the data value in spot 5. And so this is assuming that your data is in order from least to greatest. So if you count 1, 2, 3, 4, and 5, those are the two numbers we just found right there, and we added them together and divided by 2. So we averaged them out. That's the same thing this is doing. This is telling you which data values you need. So we're going to do the same thing for Q1 and Q2. All right. So I've rewritten my numbers there. Q1, we are going to find the numbers that we should use by multiplying 0.25, so this is the locator for Q1, 0.25 times 8. So 0.25 times 8 is 2. If you get a whole number, you need to use the data value in that position and the next and average those together. So the numbers in place 2 and 3 are 60 and 62. So we're going to average those. So add them together and divide by 2, and we'll get 61. So Q1 is 61. And now we're going to do something similar for Q3. So for Q3, we're looking for 0.75 times 8 because it has 75% of the data below it. So 0.75 times 8 is 6. Again, we got a whole number. So we're going to use the data in spot 6 and spot 7, and we'll average those together. So 4, 5, 6, 67 is in spot 6, and 69 is in spot 7. So we're going to add those together. So 67 plus 69 divided by 2, and when we do that, we will get 68. So Q3 is 68. So there is our 5-number summary. We have our min 59, Q1 61, Q2 65, Q3 is 68, and the max is 70. Now we can use that to draw a box plot. So that's what we want to do next. Okay, so to draw a box plot, you're going to draw a number line, and you're going to make sure you include all the numbers that are relevant to your 5-number summary. So our number line has to include from 50 to 79. So I think I'll be able to go in increments of 1 because they're relatively close together. Okay, and I have 59 through 70 on there, so perfect. If you have your a really widespread set of data, like maybe your min is 7 and your max is 128, well, you wouldn't want to go in increments of 1, you'd go in increments of maybe 5 or 10 or whatever is appropriate for your data. So you're going to draw a box for your Qs. So Q1 to Q3 is going to be in a box. So these middle ones form a box. Okay, So it's called a box plot because you're making a box out of your quartiles. And then what you do is you draw what's called whiskers for your min and your max. So your two outside values are just going to get whiskers. So let's start by drawing a box. So we have from 61 is our min to 68. Oh, I'm sorry, not our min. It's our Q1. And 68 is our Q3. And we're just going to draw a box. And this should be, you know, a rectangle. I'm drawing it freehand here, so it's not exact, but it should be a rectangle. And then your median is going to be a line in the middle of your box. And maybe it's not exactly in the middle, it just depends where the median falls. But you'll draw a straight line from top to bottom of your rectangle where the median is. So there's your box. Again, your left side of your rectangle is from Q1. The line in the middle is Q2, which is your median. And the right side of the rectangle is from Q3. And now you're going to draw a line from the middle of your rectangle to the max. So from here over to 70, and you're just going to draw a line where 70 is. And then you're going to do the same on the left side of the rectangle. So right in the middle of the rectangle, you're going to start going to the left, and you're going to keep going until you get to 59, and you're going to draw a small little vertical dash there. And so that represents your min, and the right-hand side represents your max. And that's it. That's all there is to a box plot. So let's look at another example. So number 2, we have a table that provides the tuition rate in dollars per credit hour at a sample of 15 colleges and universities. And so with that, we want to find a 5-number summary, and then we want to draw a box plot for the data. So the first thing we want to do is rearrange our data so that it's in order from smallest to largest. So that's where I will start. So I'm going to pause this, write out my list, and then I'll come back. Okay, so I've put these numbers in order from least to greatest. So your smallest is 87 and your largest is 1400. So you can see there's quite a big difference between your least and your greatest this time. So your minimum is 87. Your maximum is 1400. And now you want to find your quartiles. So we're going to do Q1, Q2, Q3. So to find Q2, well, I guess we can go in order. Find Q1. So locator for Q1, it's 0.25 times n. This time n is 15. So 0.25 times 15 is 3.75. Now, this is actually easier if you don't get a whole number. If you don't get a whole number, you always round up. So it will always round up. So 3.75 will round to 4. So you're looking for the data value in place number 4. And you do not have to do any averaging. You just use that number. So 182 is in place number 4. So 182 is Q1. Okay, now we're going to do locator for Q2. So Q2 is in the middle, so it's 50%, so 0.5 times 15. When you do that, you'll get 7.5. Again, it's not a whole number, so you round up to 8. So you're looking for the value in place 8. So 5, 6, 7, 8 is 221. So 221 is Q2. And now you're going to locate Q3. So that's 0.75 times 15. And when you do that, you get 11.25. Again, always round up. So that will be the data value in place number 12. So we know 8 is 221. So 9, 10, 11, 12 is 315. So 315 is Q3. We now have our 5-number summary, so we just use that to draw our box plot. So the box plot is just a graphical way to show the 5-number summary. Okay, so I've drawn a number line, and I had to be able to include all of my values from the minimum to the maximum. So in order to make it feasible, I had to go in increments of 100. So first thing I want to do is start off with the Q1, Q2, and Q3. So I start by looking at Q1 and Q3 to draw a rectangle. So Q1 is at 182. Q3 is at 315. So then I'm going to connect those to make a little rectangle. In this example, if you're just looking at the box plot, you would just have an estimate of where it is. So you could always, maybe you want to label what they are so that it's clear, because otherwise you wouldn't know exactly where the Q1 was. You'd know it's somewhere between 1 and 200. It's closer to 200, but you wouldn't know what the value is. So it's helpful to label. And then Q2 is 221, so you're going to draw a straight line somewhere in the middle of the rectangle. So this time it should be closer to the 200. Again, you can label 221. Now let's see what happens with our min and max. You don't have to make them different colors. I'm just doing it to illustrate a point here. So your 182 is your Q1. Your min is 87. And so that will be somewhere right here. And then your max is 1400. Way over here. Right? And again, you can label these so that it's clear exactly where they're going. You can see, I guess, the issue here. You've got this one value, this one extreme value, which you might call an outlier, all the way to the right. And so it makes your graph have to be really, your number line have to be really large and in huge increments in order to accommodate the big range in values. It does make your little box not as easy to read, and so it's important to label your numbers, especially in a case like this, when it's not in increments of 1, and you may not be able to easily tell exactly what values are being used. Well, that will wrap it up for our 5-number summary and our box plots. I hope this gives you kind of an idea of another way to categorize your data and look at your data.